Hi, good morning. It's early in the morning. It's very cold here, and as you can see, it come up to the third videos for our further class. It's 2018 further clip 003. So let's try to go through a bit more details in univariate data descriptions. You may also find that the workbook that I gave you, part B, is probably related to those area as well. So what you should do after today's class, you should go through those questions in workbook. Part B should be fine to go through that. If there's any problem, as I say, you can find me. You can also send me email to ask questions. Feel free to do it. I'm very bored out here. It's been a long holiday and I do want to work, but I'll wait until the Chinese New Year's comes. I'll come back to Australia and with you guys and start working. So what you do today, we have if you see the book, they would be on page 25, chapter 1.5. So we kind of go back to chapter 1 in the earlier chapter to look at a bit more details. So let's try to read you through some information from the book first. Let me find it, page 25. You should have this in your Dropbox account. I skipped this one while I'm trying to show you how all the graphs be plotted, how those graphs look like. This is the description that we are talking about. The description, just if you have a graph, so you know that you need to tell them whether it's a histogram, a stem graph, or a box plot. And we all have very similar terms to describe all different type of plots. The first terms that you will encounter is called symmetric distributions. Right there, symmetric distributions. When it's symmetric distribution, it's more like a mirror image. So the histogram that you can see for symmetric distribution, like the look of symmetric graph, it would be like this. It always a single peak, and then like right in the middle, and both sides is likely come off the peak, and we have roughly the same factions. So that one drop very sharp, the other side need to be sharp. It can't be like you're very flat and then the other very sharp. It doesn't work that way. It's symmetrical, need to be a mirror image. Both sides need to be very similar with each other. The second description that you can see is called skew distributions. Skew distribution means like the one that is sharp on one side, the other is flat, or the other way around. If you can see a graph, I dropped the pen. If you can see a graph down there, if lots of data going down to away from 0. So let's say the starting point there is 0. If all the data, most of the data is more away from a 0, we call them negatively skewed. And if most of the data are very close to the 0, down here is a positively skewed. The way that you remember that is just copy them in your handbook, and then you can always go back. Because it's very, if you have your workbook with you, you can always take that workbook, the notebook that you have to the exam. So I find it very confusing sometimes. So I won't be able, most of the time if I ask, what is the graph positively skewed look like? I have 50% to guess right. If I do the class right now, the next few days when you ask me, I can still remember. But after a few days, I always get mixed up because the negatively is kind of like opposite, is moving away from a 0, while negative means something else for me. Yes, if you find it difficult, don't worry about whether you can remember or not. Is easy. You can have your notebook with you You can always go back to have a look. But you do have to, question will ask you. There's a lot of questions asking you how to describe the distribution for your data, and that skewer distribution, positively and negatively related to it, right? And then you will also see other graph. So except a histogram or bar chart, it has a particular patterns to describe. Similar patterns can be described applying onto box plot as well. If I can find that box plot on page 40 right here. So box plot is something that I think we're all familiar with. A whiskers and box plot look like you have the minimum values that move up to the Q1 is the whiskers, and then the middle box is between Q1, Q2, and Q3. Then from Q3 onward is to the maximum value would be the second whiskers. Each of the section there, we call them quartile because it consists of 25% of data. It's interesting to say 25% of data, but if you put a number in there, so let's say if you have 800 students to data collect from them, so 25% means 200. Yes, if you have a bigger population, so lots of the survey been doing in a large population, let's say 100,000. So for 100,000, quarter would be 250,000. Oh, 25,000, not 250. So 100,000 would be 25,000 for each quarter. So 25% for each section. You can put them either horizontally or vertically. Means exactly the same thing, but for horizontally, from the like from 0 or from the left hand side moving bigger to the right hand side, while when you do vertical, the bottom one would be closer to the 0 and move all the way up. That's simple. Then how do we apply those like symmetrical and skewer terms into box plot? This is the way that I highly suggest that you copy this down to your notebook. Then you always have this to kind of like to make sure that I know when I see those graphs, they would be symmetrical. When I do look at the other graph, they will negatively skew. The most important part that we want to look at is the box. The box tells you whether it's symmetrical or not. If you have a symmetrical data, the box will be 50-50. So this box here, half of the rectangle and the second half, they have exactly the same size. So we call that as a symmetrical box plot. Then if you try to look at negative skew, most of the data is away from 0. It's very big values. So away from 0, you will see that in the boxes there, the first it's not half, but the first part of the rectangle inside the box would be bigger than the smaller one. And vice versa, if most of the data are closer to the 0 point or closer to the starting point, and that is positively skewed. And the median is to the left for the positive skew box plot. So you do need to describe like if your question asking you, please describe the shape of the box plot, you do need to say that the median is to the right of the center inside the box, then it is negatively skewed box plot. So things like that you would be using a lot when we try to describe a different graph, right? So hopefully those symmetrical negative skew and positive skew is in part 2 in your workbook. Please go through those questions and you should be able to master those description like the shape, and it's a matching game. You just match these terms to the graph, right? Now we've done kind of like the histogram as well as box plot for the description words. So, and then what we'd like to do today, mainly, I'd like to go through a terms You can see this a lot. SD. What's SD? SD stand for standard deviations. STANDARD, standard deviations. If you need to look at the book, is on page 54. Just go through them, page 52, 3, 4. You will find that in 1.9, standard deviation of a sample. Standard deviation. When you look at standard deviation, the terms that always come with it is spread. How closely they spread with one another, or how widely they spread with one another. I can give you a very quickly example. Let's say I have 5 entries. So this is 2, 2, 3, 5, 8. So this is first set of data. Let's say is how many hours you study per night. Then the second group of students from other school, that would be like 6, 1, 2, 1, and 9. You have 2 sets of data right in front of you. This is from first school, that this is from the second school. So let's say this is a school from the city, and this is the school from Hawthorne. Now we compare 2 sets of data now, and then I'll need to ask you a question. Compare with the spreading. So which one are more closest with one another, and which one is a bit more further away? You can try to highlight the smallest one. Here is 2 and 2, and the 8. And the second one is 1, 1, and 9. By looking at the range of those students, 3 out of 5 is between 2 and 8. It's like either like 2 and 8. You have 6 in between them, 6 hours in between them, while the second one is 1 and 9. You have how many? 8 hours between them. It's basically a bigger range already. And then you try to look at the other 2 values. We have 3 and 5. There's 2 in between them. And compare the other 2 is 2 and 6. We have 4 between them. So looking at these, even though there's like only 5 entries from each school, you can tell one of them are more compact, the other one are more spreading. So the one that with more compact will have smaller standard deviations, while the one that with the bigger spreading around among each other would be a bigger standard deviations. So standard deviation is a way to describe how wide those data or those entries away from each other. Some of them are kind of like very compact and close with one another. Some other are very wide apart. Then standard deviations is a mathematical kind of values. From each one of the data there, you can use a formula to find out what is the standard deviation for each populations. I can tell you straight away like what the formula is. Like there's a way that you slowly develop those formula. The book has done a really good job. We try to explain it. So what do we do? Here would be the formula that you need to remember. S stands for standard deviations. Then there would be a different shapes that we try to look at. The funny shape, like the kind of the mirror image of the E, like the E there, or you have like a Z mirror flipped. It represents the sum. That is not. I'm actually familiar with this shape, these symbols a lot, because Excel uses just have the same symbol, and it always means sum. So sum of the whole column, so add all the values together. The sum of x and the x means x minus x means, what is the first x represent? The first x represent an observations, or you can say the entries. How many entries do I have in here? I've got 2, 2, 3, 5, 8. So I've got 5 entries. I use 2 minus the mean of the overall, and then the second one, and then 3 minus the mean, 5 minus the means, and so on. Let's go back to the book. Then x with a slash at the top, it means the mean, the average of all the observations or all the entries. N is funny thing, it represents just the number of observations. So the number of observations I have before is 5, and it's funny that you don't just divide it by 5, you divide n, take away 1. So for this one there, you'll find that standard deviation is equals to the square root of the sum of all the entries minus the mean square root over n minus 1. It's hard to remember, I know that, but it's just, yeah, as I say, you copy this one in your notebook, then you can always go back to look at them. The very good news is you have your calculator, and the calculator is one button, so just press, if you've got all the data in there, then press one button, you'll find the correct answer. So as Excel, if you have Excel there, you would like to find out the standard deviations for the data that you have, then one button is all enough. And sometimes you will find that standard deviation for populations, they don't write SD, they don't write S, they use this symbol to do it, a sigma. A sigma is another way to write down standard deviations. So let's go back to here. So what would be the standard deviation of the first set of data and the second set of data? The sigma of it. Or some people say S, or some people just write down standard deviation. They all exactly the same thing. Refer to the formula. The formula is the square root of the entries x, take away the sum of the entries, take away the mean. Then you square it over n minus 1. It's hard to remember, but if you put them in a table form, sometimes it would be easier for us to work with. So what is the table like? The table, first of all, we need to have x, and then we have the mean, then we have x, take away the mean, and square it. So just 3 columns, and then you try to work it out after we've got all the values in the table. First one is 2, 2, 3, 5, 8. So let's try to write this down. It's 2, 2, 3, 5, 8. What is the average of it? I need to rely on the calculator. 2, 2, 3, 5, 8. 2 plus 2 plus 3 plus 5 plus 8. I have 20. 20 divided by 5, 4 would be the mean. Wait, 4 is the mean. I've got 10, 20, so 4 is the mean for every single thing. Right? Then I've got the calculation. 2 take away 4. When you have 2 take away 4, it's a negative 2. No one likes to deal with negative number, even a good mathematician. So they develop a method. Just square it. Then when you square it, every negative number would become a positive. Negative 2 times negative 2 would become positive 4. So the only reason that the square, you find the square right there, is changing every negative number into positive. At the end, you just do the cancelling. The square is square root So if you have square root and then square, basically cancel those numbers, but change all the negative into positive. So that's kind of a tricky way to make the number look better. The second one again, 2 minus 4 square is 4. Then 3 minus 4 is 1. So it's 2. 5 minus 4 is 1. 1 square is only 1. And then 5 minus 4 is 1. 1 times 1 equals to 1. 8 minus 4 is 4 square. 4 square means 16, right? Now we've got these particular tables. Then this is the important part. This one means the sum of the whole columns from the very first one all the way down. 4 plus 4 plus 1 plus 1 plus 16. 4 plus 4 is 8 plus 1 is 9. 9 plus 1 is 10. 10 plus 16. So 10 plus 16 equals to 26. So the sum there is 26. Right? If we've got that 26, we have the sum of the x take away x mean square, which is the upper part of these fractions. We have sigma, standard deviation, equals to square root of 26. And what is n? N is number of entries. Number of entries here is 1, 2, 3, 4, 5. We've got 5 entries. 5 take away 1. So just change n into 5. Then 26 take away 4 and put a square root of it. Let's try to do calculator. What do we have? We have 26 take away 4. 6.5 square root of it. Square root of 6.5 is 2.549 blah 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 blah. 2.55 is pretty good number. 2.55. Done. That is how we do standard deviations. Yes, that's not a, like if you only have 4 or 5, it's pretty easy. You can do it like by hand, put the tables, it's all done. If I give you 200s, no one would dare to try to like get all this, and most of the people just put the data into the calculators or a computer and press the buttons with it. Yes, just get one more as we try to compare between the first one and the second one, and what would be the standard deviation we expect that is bigger, and how big would that be? Now let's do the 61219. So we change that one into 61219. That's 61219. Yep, that's good. And we also need to calculate the mean. The mean is not the same. That's 9 plus 1 is 10. 6, 9, 6, 7, 8, 9. So 19 divided by 5. Let's change it. That's a bit too big here. If I change that one into 2, that would make it into 20, and making it 20 would be much easier to calculate. So 61229. So you can tell basically all the numbers I didn't prepare before, I make it up, and then I just make sure that works now. 6, 7, 8, 9, 10, 11 plus 9 is 20. So if we add all of them together, which is equal to 20. And what is mean? Mean is 20 divided by 5 of them equals to 4. We have the 4 again. That would be easier for us. So even though I have the same mean, but because the data are different from the very first set, let's see how would that change for the standard deviations. First one, 6 minus 4, still 2. 2 square equals to 4. 1 minus 4 equals to 3. Negative 3. Negative 3 square makes 9. Have a look. When you have 1, the value jump to 9. 2 and 4 is 2 square equals to 4. 2 and 4 again, 2 square equals to 4. 9 to 4 would be 5. So we have 5 square equals to 25. And we've got this 4 plus 4 plus 4 plus 25 plus 9. Let's add all this here. 4 plus 4 plus 4 equals to 12 plus 9 plus 25. 12 plus 9 is 21. 21 plus 25 is 46. Yep. So now we've got the answer here equals to 46. Compared with the one that before we only have 26. Now we have way bigger. So if you find that, what would be, let's say this is sigma from the first school and sigma from the second school would be equals to square root of 46 divided by also 5 entries. Take away 1. We have square root of 46 over 4 equals to, I have no idea, 46 divided by 4. 46 divided by 4. I have 11.5 square root. Square root of 11.5 is 3.39. Okay, 3.39. 3.39. 2 school. The first school has a standard deviation of 2.55. The second school has the standard deviation of 3.39. By looking at the standard deviation, we can tell, okay, both of the schools have exactly the same mean, but the second school has a few students that's really bad, a few students is really good, while the first school is a bit more constant among the students, right? So you can tell what happened to each school by looking at their standard deviations, right? So what's the time? So we've been doing about half an hour. Let's see, we may be able to do one last thing. That's simple. Let's move on. So this is from the book. You can tell we have exactly the same tables. This one is much bigger, and you can find the totals. The top set. Yeah, exercise 1.9. Let me see. Yes, that's the one. Very good. Thank you. So the very last thing for today, you would need to be able to display those data. If you have a set of data there, you need to choose what is the best way to describe it. So for the question here, we choose the stem plots. So we've got a stem plots here to describe those data. But this is not the most important part for all statistics. The most important part of all statistics is called summary statistics. And the summary statistic is just measure 3 things, as you mentioned before, the middle one and the distribution. Like how likely would be the middle, and how would they like for the shapes and the distributions. So the data here would be the most important for all the data. Very first one, we say the first one, x slash there means the mean. We need to find out the average. I have the average for those 12 students here. Then the second thing is the standard deviations. I've got the standard deviation there. I find the Q1, we find the median. Q2, we find the Q3. And those 5 values would be the core values that you can tell or compare between different set of data. To measure the center of the distributions, the mean and the median are used, right? And the distribution is approximately symmetrical because of the display graph here. And if you plot this as a box plot, you can see the box will be 50-50, very similar. And the mean is very close to the center of the distributions. And the mean and the median are close in values. Can you see the 33 and 32? So that is the way that you use to describe those graphs. And then we continue on. To measure the spread of the distributions, standard deviation and interquartile range are used. The S equals to 6 means the distributions is about bell shapes. Oh, that's a bit too much in here. But like, yeah, the distribution, the greater one, are they talking about the skew? Yeah, here's the next one. The distribution is approximately symmetrical. All belts very spread out. And you have the last one. The interquartile range of the school is 25, and the middle 50% is within $25 of each, which is greater than the other school. This is a very important, I'll say this paragraph. Displaying data is a very important paragraph, that from just one set of data you can say that you can write a whole page. And this is what statistics do. Just based on the data, you just blah and blah and blah and blah and give them all the values, then give them all the information you can extract out from them. And by the end of this term, you're required to write something like this. I'll give you a set of data, you write this down, it's all done. And that's kind of like important part of the SAC as well. So you'll be able to analyze your data as well as try to describe the center, describe the spreading, and describe the shape, right? So hopefully I give you a bit more understanding about standard deviation today. And yeah, we'll stop here. It's the end, and please start doing your questions. Okay, thank you. Bye bye.